In this video, we're going to do some extra examples computing limits using the limit laws. So let's start with the part A here. So we want the limit as x goes to 1, and we have the product of two polynomials. So x cubed plus 2x minus 1 times x squared minus 4. Now the limit laws tell us that, I guess I'll write this out. So assuming that both of these limits exist, we can actually do, I don't want the bracket there. We can do the limits separately. So x cubed minus 2x minus 1, and then multiply them after. Okay, now both of these limits do exist because they're polynomials. And for polynomials, we can just plug in the value of the limit. So this is going to be 1 cubed minus 2 times 1 minus 1 times 1 squared minus 4. So I get negative 2 times negative 3. So this limit value is positive 6. Okay, now in the next one, I want, again, the limit as x goes to 1. And here I have the quotient of two polynomials, where if I plug in 1 into the bottom, I don't get 0. Okay, so that means that I can compute the limits of the tops and the bottoms separately. Okay, so x squared minus 1 divided by the limit of the bottom. And again, they're polynomials, so I can just plug them in. So 1 squared minus 1 over 1 plus 1 is 0 over 2, which is 0. So this limit approaches the y value 0. Now in part C, I have the exact same inner function expression in my limit, but here I'm going to minus 1. So now I need to do a bit more work, because if I try to plug in x equals minus 1, I get minus 1 squared minus 1 over minus 1 plus 1, so I get 0 over 0. 0 over 0 means do more work. Okay, so here, what I actually need to do is factor the top. So that's the difference of squares. So I get x plus 1 times x minus 1 over x plus 1. So now I can cancel out these x plus 1s. And the rule 7 says that this limit I'm looking for should be equal to the limit as x goes to minus 1 of just x minus 1. This is a polynomial, so now I can just plug in minus 1. So this limit should approach minus 2. Okay, for part D, similarly, if I plug in x equals 7, I'm going to get 0 over 0. So I need to simplify the expression before I'm able to calculate the limit. So what I'm going to do is I'm going to make a common denominator on the top and the bottom. Okay, so on the top, the common denominator is going to be 4 times x minus 3. So I need to times the first bit by 4 over 4, and the second bit by x minus 3 over x minus 3. Okay, so I'm going to have 4 over 4x minus 3 minus x minus 3 over 4x minus 3. And then the common denominator on the bottom is going to be 7x. So I'm going to times the first bit by x over x, and the second bit by 7 over 7. So I'm going to have x over 7x minus 7 over 7x. Now I'm going to put these things together. Okay, so I'm going to have 4 minus x minus 3 over 4x minus 3 all over x minus 7 over 7x. Okay, now I have a fraction over a fraction, so I can flip the bottom one and multiply instead. I'm also going to simplify on the top here, so that negative goes through, so I get 4 minus x plus 3 over 4x minus 3 times 7x over x minus 7. Okay, now if I simplify this part here, I have 4 plus 3 is 7, and then a minus x. So it's going to be 7 minus x, okay, times the 7x over 4x minus 3, x minus 7. Now I would like to be able to cancel these factors. They're very similar, but not exactly the same. So what I want to do is make them exactly the same. So I'm going to factor out a negative 1 from the top one, and then it's going to be x minus 7 instead. So now I'm able to cancel these x minus 7's, and I have the limit as x goes to 7 of negative 7x over 4x minus 3, and I think now I can plug in 7. So I get negative 7 times 7 over 4 times 7 minus 3. So this is negative 49 over 4 times 4, which is 16. So the limit is going to approach negative 49 over 16. Okay, again, if I plug in x equals 5, I get 0 over 0. So I need to simplify the expression. Because of the square root, I'm tempted to multiply by the conjugate. Okay, so that's 3 plus the square root of 2x minus 1. And whatever I do to the top, I'm going to also do to the bottom. Okay, so let's see if this helps. Okay, so if I expand the top, I'm going to get 9. Maybe I'll write this out a bit. So it's a difference of squares, so I'm going to get the 3 squared minus the 2x minus 1 all squared. And I'm not going to expand the bottom because I'm hoping to cancel this 5 minus x factor. Okay, so then I'm going to have 9 minus 2x minus 1 over 5 minus x times 3 plus the square root of 2x minus 1. Okay, so simplifying on the top, I have 10 minus 2x Okay, so I want to cancel this 5 minus x, and I see that if I factor out a 2 on the top, that I might be able to do that. So there's a common factor of 2, and then I'm left with 5 minus x. Okay, so now I'm able to cancel the 5 minus x's, and I get the limit as x goes to 5 of just 2 over 3 plus square root 2x minus 1. And I think now I can plug in 5, so this is 2 over 3 plus square root of 2 times 5 minus 1. Okay, so that's 2 over 3 plus root of 9. So that's 2 over 6, which simplifies to 1 over 3 for our answer. Okay, a couple more limits to do. So here, I want the limit as x goes to 1 of negative 5 over x minus 1 cubed. Now notice if we plug in, or try to plug in, x equals 1, we're going to get negative 5 over 0 cubed. So basically negative 5 over 0. So when you have a non-zero number divided by a number that's really small, this is going to plus or minus infinity. Okay, so I think that this limit does not exist. So what I want to do is think to decide if it goes to positive infinity or negative infinity or neither. So here I'm going to look at the one-sided limits. Okay, so let's say we go to 1 from the right first. Okay, so let's do this below. I'm going to switch colors here. Okay, so as x goes to 1 from the right, x minus 1, we already said is going to 0. But I want to know how I'm going to 0. So if I'm approaching 1 from the right, that means I'm slightly bigger than 1. So I have something slightly bigger than 1 and I'm subtracting 1. I'm going to get a 0, but I'm going to be a positive 0. Okay, so I'm going to approach the 0 from the positive side. Okay, so then if I cube this number, okay, I'm still going to be a positive number. Okay, when you cube a positive number, you get a positive number. And then, so then I have negative 5 over this positive small number. So I have a negative number divided by a really small positive number. This is going to go to negative infinity. Okay, so this limit is, this one-sided limit, it doesn't exist. Okay, but it's approaching negative infinity. Now what happens if we approach from the other side? So from the left, okay, so now as x goes to 1 from the left, so I'm slightly less than 1. So when I subtract 1 from something that's slightly less than 1, I'm going to get a negative number. So it's going to be 0, going to 0, but it's going to approach on the left. So it's a negative number. Now when I cube a negative number, I still get a negative number. So I'm still approaching 0 from the negative side. So now if I think about the whole thing, I have a negative number, non-zero number, divided by a negative really small number. I'm going to be positive infinity. So this limit doesn't exist, but it goes to positive infinity. Because these one-sided limits are different infinities, we're going to write that our two-sided limit does not exist. Okay, let's try another one. So here, again, I'm approaching x equals 1, or as x goes to 1. If we try to plug in x equals 1, we get 1 squared plus 3 times 1 minus 4 over 1 minus 1 cubed. So we get 0 over 0. So we should try to simplify this. Okay, so which means that I want to factor the top. So I want two numbers that multiply to give negative 4, add to give positive 3. So that's going to be x plus 4 and x minus 1. And now I'm happy because I see I can cancel one of these x minus 1s. So my limit is going to be equal to the limit of x plus 4 over x minus 1 squared. Okay, now if I try to plug in again x equals 1, I get 5 over 0. So again, like it was in the last one, I have a non-zero number divided by something going to 0. This is going to one of the infinities. Okay, so again, I need to think of the left and right limits. So let's think as we approach 1 from the right. And I'm just going to talk about this reduced form because it's equal to the one that we care about. Okay, so as x goes to 1 from the right, x plus 4 is going to 5. Okay, and x minus 1, actually here, maybe I should have started with the bottom. Sorry about that. Okay, so x minus 1 is approaching 0. So I'm slightly bigger than 1. So I have a number slightly bigger than 1 minus 1. This is going to be a positive 0. Okay, now I'm going to square it. So that's still going to be a positive 0. And x plus 4 goes to 5. So our whole function, x plus 4 over x minus 1 squared, is going to 5 over a positive small number. So that means this is going to positive infinity. Okay, so this one-sided limit doesn't exist, but it's going to positive infinity. Now we want to do the same thing on the left of 1. Okay, switch back to green. So as x goes to 1 from the left, x minus 1 is going to 0, but now a negative number because I'm smaller than 1, so when I subtract 1 I get a negative number. And then I'm going to square that number. So I'm still going to 0, but now my number is positive. Okay, and x plus 4 is still going to 5. So x plus 4 over x minus 1 squared is going to 5 over a positive number. So a positive small number. So this one's also infinity. Positive infinity. So because they're the same, we would say that our two-sided limit goes to positive infinity. Okay, but remember, it still does not exist, okay, but both sides go to positive infinity, so we write that it goes to positive infinity. Okay, one more limit to do. So we want the limit as x goes to 3 of this function that's piecewise defined, okay, where it meets at 3. So in order to compute this two-sided limit, we're going to have to look at the one-sided limits. So if I go to 3 from the left, so I'm slightly smaller than 3, that means I'm in this interval here, which means I want to use this function. So this is going to be the limit as x goes to 3 from the left of 10 minus 2x. So the limit laws tell us we can plug in 3 here. So this is 10 minus 2 times 3. So 10 minus 6 is square root of 4. So this limit is approaching 2. And now I want to look at the limit from the right of f of x. So here I'm slightly bigger than 3. So I want to use the other part of the function. So it's x over x plus 3. When I plug in 3, I get 3 over 3 plus 3. So 3 over 6, which is 1/2 for this limit. Okay, now these things are different. Okay, so we got different values for each of the one-sided limits. So that means that our two-sided limit that we cared about does not exist.